Welcome to the Design Management and Office Evaluation training video. This video will discuss how to manage and evaluate an Aquatic AIM sample design. It will also cover Aquatic AIM design files and key design elements, the design management process, including how to evaluate Aquatic AIM sample points from the office, how to plan efficient field trips, and how to use design management spreadsheets. All of this information is available in the Site Evaluation and Design Management Protocol. This video will follow the design management process that is outlined in Figure 1 of the Site Evaluation and Design Management Protocol. First, this video will discuss key concepts and tools used within a sample design, including the Design Management Spreadsheet. It will then cover how project leads will select targeted points, merge points, and indicators for their field office. Next, it will discuss the office evaluation process, including how to evaluate points from the office and how to replace failed sites. Then it will cover how to organize trip plans for visiting and evaluating sites in the field in the most efficient manner. Next, it will cover field evaluation when sampling crews visit sites in the field. Finally, it will cover how to assign a final status to each Aquatic AIM sample point and how to finish the sample design to be submitted back to the National AIM team. An Aquatic AIM sample design is a framework or roadmap that serves as the basis for the selection of Aquatic AIM sample points and affects many other important aspects of a survey as well. Aquatic AIM sample points are designated as either targeted or random. Random points are generated with a computer algorithm to be spatially balanced across the landscape and are usually sampled over a predetermined period of years. Design management is the process of documenting site evaluation outcomes, both office and field-based, for Aquatic AIM points. Proper design management is important to both maintain the statistical validity of a sample design and support the subsequent inferences drawn from collected data. It is important to have a good design management process because it ensures crew efficiency, is part of the quality control process, avoids unnecessary creation of holes in the design, and is used during data analysis. The first step in managing a design is understanding all the elements and tools that make up a sample design. It is vital that everyone involved in an Aquatic AIM sampling effort understands these concepts. The tool used for design management is the Design Management Spreadsheet. Design management spreadsheets are created by the National AIM team and given to those collecting and managing AIM data in specific areas. Design management spreadsheets are invaluable tools for managing field crews and correctly collecting AIM data. A design management spreadsheet is basically a summary of a sample design and has a list of Aquatic AIM sites that may be sampled in the rows of the sheet. Design management spreadsheets are broken up into 3 different worksheets. The Design Management and Evaluation Worksheet, where all of the design management and site evaluation processes take place. The Trip Planning and Field Tracking Worksheet, which is used to plan field trips and keep track of sites that are visited. And the Metadata Worksheet, which describes all of the columns in the other 2 worksheets. We will go over the Design Management and Evaluation Worksheet first. The Design Management and Evaluation Worksheet has columns that are vital in managing a design, including point category for base, oversample, and targeted points for each Aquatic AIM site, strata categories, unique site codes for every point, and in what year each point should be sampled. The next several slides in this video will discuss what each of these fields are and why they are important for managing an Aquatic AIM sample design. Aquatic AIM sample points can either be randomly selected or targeted. The National AIM team and project leads work together to decide what kind of design is most appropriate for determining if randomly selected points, targeted points, or a mixture of both should be used in the sample area. Random points are selected by a generalized random tessellation stratified computer algorithm, are spatially balanced across the landscape, and are usually sampled over a few years. This random point generation method allows for broad-scale statements regarding the overall condition of a resource. It also enables data to be analyzed later at different scales that cannot always be predicted during the design phase. Random points can be moved if necessary and will have to be replaced if they fail. Rules on moving these points can be found in the 1735-2 Field Protocol or in the Moving the Point Coordinates training video. This video will discuss how to replace failed points later on. These random points are designated as either base or oversample. Base points are points in a random design that correspond to the desired sample size for a given strata. Ideally, all base points would be successfully sampled. However, for a variety of reasons, base points are frequently rejected. Oversample points are points in a random design that are used as replacements for base points that are rejected or cannot be sampled. Targeted locations are hand-selected by project leads and can be used to answer reach scale questions. Although sampled using identical field protocols, targeted sites are processed differently a priori than random points. For example, targeted points should not be moved without first consulting with the project lead and typically do not need to be replaced. Aquatic AIM random sample points are divided into different strata. These strata are usually defined by their location, commonly a BLM field office, and a size classification, defining the stream as either a small stream, large stream, or river. There is a minimum sample size determined for each stratum, and each stratum is considered independent of the other strata in the design. For example, this strata is for small streams located in the Royal Gorge Field Office, and this strata is for large streams in the San Luis Valley Field Office. Each strata is represented by a different color in the Design Management Worksheet. A site code is a unique code for each point in a sample design. It is used to track all information about a given point location, including whether that point was sampled or rejected, the data associated with it, and the number of macroinvertebrates and water quality samples associated with it. Site codes are broken up into a letter code, either 2 or 3 characters, that represents the sampling group or strata. SS stands for first and second order small streams. LS stands for third and fourth order large streams. RV stands for fifth or larger order rivers. The 4 or 5-digit number that follows is a random number assigned to the point. For example, RGSS 10377 stands for a site that is in the Royal Gorge Field Office, is on a small stream, and has the random number 10377. The year column in the Design Management Worksheet indicates the year that a point should be sampled. The year panels help introduce temporal variation into the data while ensuring spatial balance is maintained. The next step in managing a design is selecting targeted and merged points and indicators. This is commonly done by the project lead, who usually works for the BLM. By looking at the array of base points within their sample design in the Design Management Worksheet, project leads can decide if they would like additional monitoring done in places that are not represented by a random point. These points, called targeted points, will then be added to the overall sample design and included in the Design Management Worksheet. For example, a project lead may want to assign a targeted point to a stream in their field office that has been altered by past mining activity and will undergo restoration work. This will allow for the project lead to get data for the stream before the restoration work is done, and can therefore be compared to data that is collected after the work is done in repeat sampling efforts. In some rare instances, an identified aquatic AIM site may be located near another monitoring location on the same stream. If sites from the same AIM design are located close to one another, project leads may skip one of the AIM sites. If an unsampled AIM site is located close to another previously monitored location from a different design or monitoring effort, Project leads may merge the locations by moving the aim point to the pre-existing monitoring location. When project leads merge or skip sites, they ensure that there is no difference in geomorphology, management, or flow between the two sites being merged or skipped. Merged sites should be recorded as such in the merge column, and skip sites should be recorded as too close in the Office Evaluation Status column. Next, the project leads should choose which, if any, covariate and supplemental indicators should be collected at a given site and record it in the Indicators to Collect column in the Design Management Worksheet. For example, a project lead may choose to sample in-stream habitat complexity, also known as fish cover, because they have management questions related to fish population and health in their field office. Those that are managing the design should get in contact with project leads and the National AIM team if they have questions on why certain indicators were chosen for a given site. Once targeted points, merged points, and indicators are selected by the project lead, the next step in the design management process is office evaluation. Office evaluation is the process of using different evaluation techniques in the virtual environment to determine if the random points within the sample design should be visited or replaced in visited. This process is commonly done by project leads, hiring organizations, or field crews. Columns within the Design Management and Evaluation Worksheet that are useful in this evaluation process are the Evaluation Status, Evaluation Comments, and Reject Evidence columns. Office evaluation is used to determine the location, access, and sampleability of aquatic AIM sample points. Virtual evaluation is commonly conducted using aerial imagery and local knowledge from those familiar with the sampling area, such as BLM field office personnel. Tools like GIS, Google Earth, Google Maps, and topographic maps can be used to evaluate points and determine driving and hiking directions. When conducting office evaluation, there are several things that must be taken into consideration to ensure that the design remains statistically valid. All points in a design are intended to be sampled in the order in which they appear within each stratum in the Design Management Worksheet. As discussed earlier in this video, random points are divided into base and oversample points. Base points correspond to the desired sample size for a given strata and should therefore be evaluated in the office first. Let's look at an example in this sample design. This design contains 10 base points that need to be sampled or replaced with an oversample point and sampled before the field season is over. The design is broken up into 4 stratum that represent the 4 regions within the field office and contain 1 or more base points each. Listed under the base points for each stratum is a list of oversample points that can be used if the base points are rejected. It does not matter which order the stratum themselves are evaluated in, however, the first base point within each stratum should be evaluated first, followed by each consecutive base point. For example, in the San Luis Field Office Small Stream Stratum, the base site Small Creek should be evaluated and sampled first, followed by Kerber Creek and Beaver Creek. If any of these sites are rejected, it should be replaced by the first oversample point that is listed within the Design Management Worksheet within the same stratum. This replacement is made in order to ensure the sample size is met. If the first oversample point is also rejected, it will be replaced by the next oversample point until one is sampled to replace the original base point. For example, if the base site Small Creek cannot be sampled, it should be replaced with Mill Creek. If Mill Creek can also not be sampled, it should be replaced with Professor Creek. This process is repeated until there is a sampleable oversample point to replace the original base point. So, at the end of the season, 1 point from the Royal Gorge Small Stream Stratum, 1 point from the Royal Gorge Large Stream Stratum, 3 points from the San Luis Valley Small Stream Stratum, and 5 points from the San Luis Valley large stream stratum should have been sampled, equaling a total of 10 sampled points. While some of the base points may have been rejected, they were replaced by an oversample point and sampled. This process is followed to avoid creating holes within the sample design. Holes result from skipped or inaccessible points that fall between evaluated points. Having too many holes in a sample design can create bias in condition estimates. For example, a hole may occur in this sample design if the Small Creek site is skipped while Kerber Creek and Beaver Creek are still sampled. Some holes are inevitable, resulting from denied access through private property or because of unsafe access or sampling conditions. As a rule of thumb, holes should not make up more than 30% of all evaluated points, excluding non-target points. Depending on the objective sample size, 1 or 2 holes in a sample design are generally acceptable. Let's now focus on the specific criteria that each site needs to fulfill in order to be visited in the field and why a site may need to be rejected and replaced. In order for a site to warrant a field visit, it must be evaluated in the office to determine if it is part of the target population, is safely accessible, and if it can be safely sampled. This is where tools such as Google Earth, topographic maps, and information from those familiar with the field office will come in handy. The first step in site evaluation from the office is to determine if the point is within the target population. Target population points are located on BLM land, have some evidence of water, must be a loadic system, and must be in a naturally occurring stream. If the point does not meet all of these criteria, it is deemed as non-target and is rejected. Next, it should be determined if the point can be safely accessed. Factors contributing to this algorithm may include obtaining permission to cross through private land, determining driving directions, and mapping hiking routes. There may be unique challenges to accessing many points, so research should be done thoroughly, especially with those familiar with the field office. If a site cannot be accessed safely, it is permanently inaccessible and should be rejected. Finally, it should be determined if the point can be safely sampled. For example, it should be determined if the stream is wadeable, or if there is a specific time of year that a stream should be sampled to avoid high flows or avoid the stream going dry later in the season. USGS flow gauges and local knowledge from those that work in the field office may be useful resources when determining if and when a stream can be sampled. If a site cannot be safely sampled, it is permanently inaccessible and should be rejected. Once each site has been evaluated in the office evaluation status dropdown in the Design Management Worksheet should be filled out. The options in this dropdown are field visit, non-target, permanently inaccessible, and too close to other monitoring locations. An office evaluation comment should also be provided with each point. If a site is rejected because it is non-target or permanently inaccessible, make sure that the correct option is chosen from the Office Evaluation Status dropdown. Non-target points can be divided into the following categories: dry, lentic, and map error. Permanently inaccessible sites are divided into not wadeable nor boatable, inaccessible terrain, or inaccessible due to private land. Rejections done in the office must be supported by 2 lines of evidence and entered in the Rejection Evidence 1 and 2 tabs within the Design Management Worksheet. For example, this point from the Royal Gorge Field Office was located on a stream channel that is very straight and flowing into a reservoir. With some further investigation, it became apparent that the stream emerges from underground from a man-made structure, and a BLM employee confirms that the feature is a water diversion ditch. This stream should be rejected as non-target map error in the Office Evaluation Status and have the appropriate comments in the Office Evaluation Comments and Reject Evidence columns. The fourth step in the design management process is to plan trips for crews to go out and sample or reject the points that were evaluated in the office. Field visits can be managed in the trip planning and field tracking worksheet within the Design Management Spreadsheet. In this worksheet, a site code can be selected from the drop-down menu that contains all the points in the design. Stream name, latitude, longitude, and office evaluation comments from the Design Management Worksheet will auto-populate when the site code is selected. The Trip Planning and Field Tracking Worksheet is used to create and keep track of trip plans. Trip plans are schedules given to field crews that usually cover the entire trip duration, which may span from 1 week to several depending on the sites being sampled and the desired work schedule arranged for each crew. Trip plans include the sites that need to be sampled, the order in which they should be sampled, the latitude and longitude for each site, hiking and driving directions to each site, and any additional notes that are pertinent when trying to access and sample the site, like landowner contact information. It is also a good idea to include this information for a few oversample points if any of the base points that are assigned get rejected in the field. Trip plans can be created by project leads, hiring organizations, or the field crews themselves. All the information that should be included in trip plans is available in the Trip Planning and Field Tracking Worksheet. When designing a trip plan, points should be visited that are geographically close to each other if possible and sampled in the order specified by the Design Management Spreadsheet. Trip plans should also consider various environmental aspects to make each hitch run as smoothly as possible. For example, those designing trips should consider the time of the year that they are visiting each site. Some sites, like those located high in the mountains or on rivers, may be too fast and deep to sample early in the season and should be put off until later in the summer when the flows have subsided. Conversely, small low elevation streams and those in desert areas may dry up later in the season and should be sampled earlier in the season. Other environmental considerations are flash floods in areas that experience monsoon seasons, dangerous mid-afternoon thunderstorms, extreme heat, and deep snow that may be present at high elevations early in the season. Another consideration to take is hiking and driving distances. It may be hard on the crew, and they may not get all of their work done if all their sites during a trip require a long hike. Long hikes and drives can sometimes require that sampling be divided between 2 days, making it hard to complete every site. So those planning trips should try to assign points that are near each other. They should also try to mix easy access and harder access sites for each trip. Additionally, it's a good idea to plan the longest hikes towards the beginning of the trip so that the crew can get it done while they still have the most energy. The fifth step in the design management process is for crews to go out in the field and sample or reject the points assigned to them in their trip plans. They are then in charge of filling out the trip planning and field tracking worksheet. Once a crew has their trip plan, they will go out into the field office and attempt to sample each point given to them in their plan. Once in the field, crews will assign each point a field evaluation status and mark the point as sampled, rejected because it was non-target or permanently inaccessible, or as revisit to be attempted again in the future. For more explicit information on reject and revisit sites, please go back to the failed sites section of the Moving the Point Coordinates training video. Once the crew is back from their trip, they should document the sites they sampled, rejected, and marked as revisit in the trip planning and field tracking worksheet. This documentation should include the start date of the trip, field evaluation date, field evaluation status, field evaluation comments, number of bug jars, and number of water quality samples taken. If the crew rejected a site as permanently inaccessible or non-target, will have to be replaced by the next available consecutive oversample within the stratum. This replacement point should be evaluated and worked into a new trip plan if it looks like it can be sampled. The data for each site should then be checked by those in charge of the crew and submitted to the National AIM team. More information on this process is outlined in the Quality Control and Quality Assurance Training video and in the Data Management Protocol. The final step in the design management process is to document the final status in the design management and evaluation worksheet for each point in the sample design and submit the design management spreadsheet to the National AIM team. In the design management and evaluation worksheet, the visit date and field status options will auto-populate from the trip planning and field tracking worksheet. The final status column for each site that is visited will then need to be completed. Final status is assigned depending on the ultimate outcome of a given point relative to evaluation and sampling status and comments. Points can be designated as sampled, non-target, permanently inaccessible, non-needed, or unknown. Points should be marked as sampled if they were successfully sampled by the crew. Points may be marked as non-target if they were evaluated in the field or office as not being part of the target population and had fewer than 5 wetted transects, were located on a lentic system, or were located on a canal or an area with no evidence of a stream due to map error. Points may be marked as permanently inaccessible if they could not be accessed because of private land access issues or terrain features. Points that are classified as not needed are typically oversampled points that fall after the last evaluated points and are not considered in analysis. Points may be designated as unknown if they were skipped, categorized as too close to another sample point, or not evaluated in the sample design, and that fall prior to the last evaluated point within a stratum for a given year. For example, a landowner is contacted because the site requires access through their land. The landowner never replies to the request even after several attempts to contact them. This site should be marked as unknown. Unknown points can have a negative effect on the statistical rigor and inference of the sample design, and effort should be taken to avoid points with such a final status. Ideally, at the end of the study, no sample points will be classified as unknown. Toward the end of the sampling season, it is very important to check that all possible base and necessary oversample points have already been or will be visited to avoid any holes or gaps in the design to ensure statistical validity. As a reminder, holes are any unknown and inaccessible points, and as a rule of thumb, holes should not make up more than 30% of all evaluated points, excluding non-target points. When the design management spreadsheet is completed, it should be submitted to the National AIM team. Let's do a quick recap on the design management process. First, the National AIM team and project lead will provide each Aquatic AIM project with a sample design and a design management spreadsheet that contains all possible points that may be sampled within their area. The project lead then selects targeted and merged points and indicators. Next, all points for each stratum should be evaluated in the office, determining if the point meets the target population, is accessible, and is sampleable. If the point does not meet the sampling criteria, it should be rejected, provided 2 lines of evidence, and replaced by the first available oversample point. This oversample point should also be evaluated and replaced if it does not meet the sampling criteria. This process continues until there is a point that can be sampled and the number of sampled points is met for each stratum. Once all the needed points for each stratum is evaluated in the office, trips that organize field visits for each point should be created. Once each site is visited, sampling information should be recorded in the field tracking spreadsheet, and a final status should be assigned in the design management spreadsheet. Once the desired sample size for each stratum is met, any additional comments should be made within the design management spreadsheet and should be submitted to the National AIM team.